Today we're going to be working with similar figures. More specifically, we're going to be working with similar triangles. So what we're going to learn today about triangles also applies to other similar figures. So triangles that have the same shape but are not necessarily the same size are considered similar triangles. They look similar to each other, but they're not exact copies. Okay, if they were congruent, then they would be exact copies of each other. To be similar, the figures must have the same angle measures as well as proportional side lengths. So the key thing to understand is if they have similar angle measures, then that means that, or exact angle measures, that means that their side lengths will be proportional. So here it says two triangles have the same angle measures if and only if they are similar. So if we go through and we compare the angle measures, we have a 95-degree angle, a 95-degree angle. We have a 65 and a 65, and we have a 20 and a 20. Because the degree measures are the same, then these would be considered similar. It means that if we knew the side lengths, they would be proportional to one another. So as long as the angle measures are equal to each other on each of the pieces of the triangle, then that means that those triangles are considered similar. So triangles ABC is similar to triangle DEF. This is a way that it may be written. Okay, they're going to use this little squiggly line instead of like an equal to. It just means they're similar to each other. It's kind of like a turned over S. Okay, so we're going to go ahead and practice this concept. So the key thing to remember, if the angle measures are all the same, then they are considered similar. Okay, so here's something that we're going to be practicing. So it says, tell whether the triangles are similar and then explain. So we're just going to go ahead and identify whether or not they're similar to each other. So we're going to look at the angle measures. Well, we have a 50-degree angle measure here and a 50 there. So far, those are the same. I need to check to see if when I check 180 minus my 75 minus my 50, if that gives me 55. Okay, and if it does, then they will be considered similar. So when you're working these, you're going to have to solve one of the triangles to make sure that you've got two angle measures that are the same, because then that means the third one is also going to be the same. So 180 minus 75 minus my 50. When I do that, I do get 55 degrees for X. Okay, I don't have to go through and check Y, and here's why I don't have to, because as soon as I had two that were the same, that means the third is the same. So here, because all angle measures were equal, this would be considered, yes, they are similar. Explain why all angles were equal to each other. Okay, even if they take one of the triangles and they turn it, as long as you've got your angle measures, then the same angle measures, then they're going to be considered similar. Okay, so here we have a right angle. So those are the same. I need to check one of the two triangles. This time I'll just go ahead and check this one. Okay, so I know a triangle is 180 degrees. Whoops. 180 degrees. I'm going to subtract off the 90 and then subtract off my 38. And it doesn't matter which triangle I pick. I'm just going to pick one of them and check it. So let's see. 180 minus 90 is 90 minus 38. It gives me 52. Okay, so we have a right angle. I have a 42 and a 52. So these are no longer equal to each other. Why? Because I can tell this one's 42. I can't have a 42 and a 38. Okay, so therefore I've already identified if I want to check, I could go through and solve for X on this side. So I would take 180 minus 90 and then subtract off the 42. That gives me 48 for this one. Okay, we're off by 10 degrees on those two angle measures. They're not the same, therefore this would be a no. Explain why, because our angle measures are not the same. Okay, so it's a yes if we end up with angle measures the same, and it's a no if we have different angle measures. Okay, so I want you to try this one. So you're going to go ahead and check. You're going to solve for X and Y, and some of you will be comfortable just solving for one of them. And then you're going to check to see, do I have the exact same angle measures? Okay, so go ahead, pause your video and work through this one really quickly. Okay, I can already tell that this one's going to be a no. Just by checking my top triangle when I went through to solve for x, I see that I'm going to end up with a 72. Here I had 71, there I had a 72. Okay, which means y is going to be a little less than, it's going to be more than 80. It's going to end up being, what, 81 instead. But I could go through and check that. But I can check one of them to identify. So this would be a no, because not all of the angle measures were the same. So let's go ahead and try one more. Okay, so in order for them to be similar, the angle measures have to be the same. So go ahead and try this one. Remember that red corner means 90 degrees. Okay, this was a yes. When I solved one of them, I can tell from solving from one of them, but if I want to reassure myself, I can solve both triangles and then just compare to make sure that all of the angle measures were the same. We have a 90 and 90, a 66, and I solved for y there, 66. Here I solved for x, a 24, and that was a 24. So even though they had taken this triangle, shrunk it down, and flipped it, it is considered similar. So that's working with similar figures. So once again, let's review quickly. Similar figures, if they are similar, they will have all angle measures that are the same. The sides may be shorter, but all angle measures will be the same in order for them to be considered similar.